All right, we're looking at log and exponential functions still. If I have log base 2 of 8 equals 3, do you guys know how to rewrite that as an exponential equation? Yeah, so whatever your base is still the base in exponential form. Okay? This is the exponent, this is what it equals. Okay? Some of you are fine with that, you know that from Algebra 2, that's great. Another way you can think about doing it is what's called exponentiate. So if I were to go back to this original log equation, and I decide, I look at my base there, it's a 2. I'm going to do 2 to the log base 2 of 8 equals 2 to the third. Okay, that's called exponentiating. You're raising both sides with a base of 2. Anytime these bases match, do you know what all of this becomes? 1. Not quite. It becomes something simple, but do you know what it becomes?
10.
6.
It's just the 8.
I was going to say that, but I thought I was going to be wrong.
What you got? Yeah.
I'm going to
Keep your mind.
Thanks.
When the bases match, no matter what they are, they don't cancel out, but they essentially do. It's just not like a fraction canceling out. You're left with just the 8. So that's another way to look at it. So this becomes 8 equals 2 cubed. Do you see how that's the same as what we did over here? Okay. We'll do more of them. So let's do one with variables then. Let's do, just to make sure you got it. Yeah. Okay. Let's say log base x of y equals z.
Love it. Should be a y z. So it should be x.
Okay. If I just see it, I know x to the z equals y. If I don't, and I want to exponentiate, what's the base on the left side?
X.
So I'm doing x to the equals x to the, okay? So what's left on the left?
You're just so bored right now. He's finding
Anything to amuse, okay. Do you guys see both the same basis? That's going to leave you with just a y over there. And then this side is x to the z. Okay? Whichever way you can convert, I don't care, as long as you understand it. Do recognize, though, that anytime you have the same bases, it's going to be just this value in here. Okay? All right. Let's keep going. What else do I want to have you do? All right. What if I give you exponential? Like, let's say I give you 10 cubed equals 1,000.
You would obviously be wrong.
Log base 10, right? Which if it's base 10, do I have to write the base? No. Okay.
Oh.
Of 1,000 equals 3. Okay. You guys have a quiz next time. You do have to be able to convert from log to exponential, from exponential to log. Okay? We okay with that? Yes.
Sorry, is the 1,000 the base or the?
Nope. What is the base? It's not written. Okay, so it
Oh,
is if the base is 10. This is the common log, okay?
So wait, if we write log base 10, we can take off 1.
Mhm. It's not the proper notation.
Or just not write anything. Or you can
Ever write a base no. Just like when we talk about natural log, that's coming up very soon here. Do you guys remember the base with natural log? E. If you write log base E instead of natural log, you're going to take off points, okay? You need to understand the right notation. We don't write log base E. Okay. So if you see, what?
We should write log.
For natural log. Is that what you're talking about, the E? Yeah, so like if you, we'll just jump right to that.
God, now we're in E's.
Let's say, like E cubed equals X. That means
10.
natural log of X equals 3. Okay? Yeah. The base is E. You just don't write E, you use natural log instead.
and he's like what, 2.7?
2.718.
Wait, why is there any? What's that symbol?
ln, natural log. Which if it's natural log, why is it ln and not nl? I don't know. Okay. All right, are we okay? We're jumping
I like
around.
that.
What?
I like that.
No, you can write. Is that better?
Wait,
Natural log is just a log that has e as its base.
you said natural 9E is equal to
718, yeah.
Does it matter? Should we know that?
You should know like 2.7. Or even just knowing that it's between 2 and 3. E is just an irrational number like pi, okay? When you get to calculus, you'll learn it has to do with the limit, and you just don't know enough math yet to know what E is.
Is like, oh, what is it?
You don't know enough math yet to truly understand what E is. It's an irrational number the way pi is an irrational number.
Okay, respectively, but like, E cubed equals X, like what is that? Is that
Just made up an equation.
Oh, but.
So that you could then write it as
So,
a
but
natural log.
E cubed equals ln X? Is
No.
that what it says? Is that what it is?
Okay, e cubed equals x, which you can rewrite in exponential form as the natural log of x equals 3.
Oh, is that ln? Is that natural?
Yes, natural log. These are the same thing. I just wrote it 2 different ways.
Oh, okay, so does E and
My L is
ln,
2 different ways.
so does E and ln X have any correlation?
Yes, what is the base over here?
ln.
No.
Oh.
So like ln is
No.
5.
10.
That's what I said. 100.
Wait.
But
47.
dude, I threw an E
Yeah,
in here.
like 10.
Good try. If it's a log without a base written, that is base 10.
10.
Yes.
what's the
This is natural log.
What's natural?
What is the only base that we ever have with natural log?
1.
What's the base over here?
2?
E. That's an
Wait.
E. Right? Isn't that an E?
So ln and E are the same thing.
No.
The base for ln is E.
Oh, the base?
Yes,
The
so like you know
base
how
of
the
this
base
is
for
E.
log is 10?
You don't ever write it there, but it's like that.
Oh, so it's like so it's like the 10 of the logs.
Are you recording
Yes.
this?
Oh my goodness, yes. I may have to re-record tomorrow. We'll see.
So wait, so
Good discussion though, guys.
so the E of the ln is the 10 of the log.
Okay.
Is that right? Am I right?
Is
Is
it?
it fun?
Alright, so then I don't understand what E is. Why is E a thing if we don't know what it is?
It's a number.
Wait,
But we're not-
You knew what pi was before you knew.
No, but I thought you said we don't know
ratio.
enough math to know what E is. I thought you said that.
You don't.
Okay.
You will
Will
in
we ever
calculus.
see this on a user test?
Natural log, absolutely.
Oh.
What about E? So does E mean anything to us, really?
2.7 is the approximate value.
Okay, what is that?
Okay, so you know how in the first part, we had to cancel everything out with a 2? With a natural log, you would use E to cancel out. Not like cancel out, but like cancel out.
Right, like if you wanted to rewrite, let me give you another one. Let's say I had natural log of 5 equals y. Okay, what is the base here?
What's the second?
Yes, so I could do e to this and e to this.
So E5 equals EY.
Okay, what's the only thing that's going to be left over here?
5.
5.
Oh.
Black and white. So E just cancels out log.
What's the base of natural log?
10.
E.
Oh.
10 is
I actually
log,
thought
E is going to be
Yeah, if you just said like,
I just like don't. Maybe I'm just like slow at learning stuff, but like what? So E is just the killer of the LN.
Sure.
in your world, yes.
But you know how like
Yes.
log has 10? I was how like E had so many.
Yeah, literally.
It's just not right.
Yeah, you're right.
Did you learn that like in algebra 2 you did something with that? Or
No, or maybe like I was just remembered.
Really strong.
No, maybe
fives with it? I don't know where you're getting a 5 from.
about that.
Okay, so let's, just to make sure we're okay, let's practice a few converting. So if I give you, let's say, natural log of 7 equals a, and I want you to convert that to exponential.
So we do E.
Is it E8 equals 7?
What?
E8 equals 7?
It's not E7 that we're saying.
Whoa.
You, think, if you're struggling to remember like what goes where and understanding that, do the exponentiating. E to that. Use your E as the killer of natural log, okay? That works.
Okay, but since you just like throw the E up there, so the LN goes away. And then what happens to the A?
It's E to the A. I'll write it out.
Oh!
Light
Teachers
bulb?
love those moments.
Yeah?
Oh, but you just like flip it back. That's what.
It doesn't matter, you can write it
Yeah,
this way.
yeah,
Yeah. Let's try another one. What if it's
No one tell me.
log of, sure, 100 equals 2.
Wait, 100.
What's the base?
Oh, why? Oh, because 10's the what cancels the log. Oh, so I just write 10. 10. Oh, so it's 10 squared equals 100. Oh, okay.
Okay, let's do one with like,
Would that be the final answer?
yes. If I said just convert, then yes, you're done there.
And then you said simplify.
Yeah, that's kind of a weird one to simplify. It's like great, 100 equals 100.
Yeah.
Yes. Okay, I think I'm right. Let's do log base 5 of z equals m.
What's the base?
5.
Oh, wait, log 5 C. And we have a C. Equals M. So it's down here.
Why?
5. So if there's no base, then you just throw in 10. Wait, but okay.
But since there is a base, we
You have to use the base that's there.
But like,
When it's not written, it's 10. It's just that's the common law.
When it's-
We know that once.
Log 100 wasn't 100 the base.
No. There was no base written, right?
Yeah, where's the base? Oh, it's times. Oh, I wrote it different. And the base is always like a subscript, is that what it's called? Oh, look at that. Alright, so now
Yeah, I need to re-record this.
Like in the last question, like
We'll
what
get
is
for something.
what is the one? Oh my
You might.
No one's good at that.
All you need to know is base.
Five
That's
and
the
I
one.
can think I have something in there.
So you should get Z equals 5 to the M on this one.
Let's go. I know.
Let's do one more just to make sure.
Sure.
Let's go back to that good old natural log. All right, how about this one? Fletcher, go.
I'm going. Is E respectively.
This is actually so. No, but like one.
Hey, we got that, right? That's what matters.
EY equals X.
And when you say EY, do you mean E2 though?
Yeah, E2 I respect.
We're not testing.
What?
Like,
I feel like you can't stop saying
respectful
that.
because I mean, I'm
Yeah,
organized.
that's
to
good.
do
Yeah.
You can say E to the Y equals X. Totally
Yeah,
fine.
obviously.
Okay, are we okay with converting now?
Yeah.
Yes, we're okay.
Love the flush. You do you. Okay.
All right.
No, I love it.
Okay, let's evaluate a little bit.
I didn't get that right there. Wow. So long. How much of that? I think I just need like a little bit more time.
That's okay. Oh my God. We go so fast. Like, I'm sorry, you had no time to understand, but we
If I
have to
were
keep
an
going.
honors major,
It's rough. It's so quick in there. Okay, so guys, this one is kind of written, it's hard to write this appropriately. The base is 7, so this is log base 7 of 1/49. For that calculator, I need you to tell me what that equals. What you are thinking about is 7 to what power is 1/49?
1 is
Negative 2, yes.
Oh.
So your answer is negative 2. So there's not really much work to show here. You just have to.
Like is it also 1/2?
No.
No. Because
That would be square root of
7. And that would be like.
Not 1/49. Okay, let's try this. Log base 2 of 64. So again, you're just thinking,
What times 2 equals 64?
not what times 2, 2 to what power? It is not 4. 2 times 2 is 4. 8, 16, 32, 64. Use those fingers. Yeah, so it is 6.
Like, see, this kind of don't get it. What's the point of writing it like that? Why wouldn't they just ask you like, oh, what square, what?
So the reason we have logs is so we can solve equations where the variable is the exponent. You have to learn how to evaluate the simple ones before I give you an equation that you solve.
Oh, so this is just like easy stuff.
It's kind of like the arithmetic of logs first. Okay. All right, let's try another one. And it's testing to see if you really know your exponent rules.
Yeah.
All right, log base 1/3 of 27.
It's gotta be another fraction, right? No. Maybe it's another fraction. Well, just 1/3 times itself is not gonna be. Oh, negative. It's gonna be negative 3. I said that. David, should you not make me say that? Alright, I don't know.
It is negative 3. A lot of you got there.
Let's go.
We okay with those? Not that one. Okay, so 1/3
I said that.
to some power has to equal 27. Okay? So first just think about 3 to what power is 27? 3rd, right? Okay. But I need it to not be down here. I need it to flip and be up.
So it's negative.
Yes.
Gotcha.
Yeah.
Okay?
We must be like really
I
slow.
know.
That's just basically like a test of who you're doing.
All right, so we're okay with those.
I did. I was like, I studied for like
I got a
There's no improvement.
Not
On a 1 to
I know,
5 to
yeah.
8.
My big one.
so. And they were like, what are you gonna do about this?
Okay, guys, for these, you're not using logs in any way. Okay, this is back to just understanding your exponents.
Oh, so it's such a simple math, right?
In theory, yes.
I feel like if I just like memorize my like, what would the add powers of like fractions and negative numbers? I mean, 8 to 8, 64.
Knowing your, like,
Yeah, because like if you were to tell me what's like 8 to the 1/2, I don't really know. Oh wait, okay, like or to the third. It'd be like what to
the cube to the 1/3.
8 to the 1.
Okay, let me walk you guys through this one. When you have an equation like this and I'm asking you to solve, and you don't really know how to solve with logarithms yet, you need to make the bases match on both sides of your equation. Any guesses as to the base we're going to want to go with here? 2, yes. Always go to the smaller number. Don't try to turn a half into 8. Try to turn 8 into 2. Okay, try to turn a half into 2. Usually the bases you're going to see are 2, 3, maybe 5, but usually 2 and 3, okay? So how do I, like 2 to what power is 8?
2 to the third.
Yeah, so this side is
2 to
2 to the third, and then that is still to the 1 minus 2x, right?
Yeah.
Because I just rewrote 8 as 2 to the third. Okay, now over here, 2 to what power, like how does a half?
2 to the negative.
Yes.
Oh, does that have to be got 1/2?
So we need to simplify a little more on the left. So this is really 2 to the 3 minus 6x. And this side is still 2 to the negative 1. Are we okay with that? Power to a power, we multiply. It's from 2.1.
Oh, you just distribute?
Yeah, just distribute right.
Oh, you
Okay.
distribute. You just plug in, like, if you just knew how 8, wait, can you get 8 to 1/2? Oh, is this gonna be a fraction answer?
Well, 8 to the 1/2 is not 1/2.
No, I'm saying like, if you're trying to find out what x is, if you just knew what 8 was, what 8 like square, or what the exponent is to get 8 to 1/2, could you like solve it easy?
Which is what we're doing here.
Yeah, yeah, but is it gonna be a fraction, because 8? Yeah, I see, okay, yeah.
All right, once you're here, guys, the bases are the same, right? What must be true about my exponents? They have to be equal. So I am now solving 3 minus 6x equals negative 1. And you're back in algebra 1. Negative
Oh, this is a math I
6x.
like right here.
You're good at this stuff? Okay, all right.
I love this. I can do this all day. I got the answer.
Did you get 2/3? Huh?
Just say no.
I know. You don't want to like crush your soul here today. Not the goal.
Thanks, guys. Thanks.
All right, we okay with
Oh,
that?
so that's the
Yeah.
Okay, let's try again. You're done. If you actually plugged 2/3 in here and did 1 minus 2 times 2/3, you would get negative 1/3 as your exponent. Think about it. 8 to the negative 1/3 is a half, right?
Yeah.
Yeah, does that make sense?
Uh-huh.
What, Anna?
Where does the 2 go on both sides?
Okay, bases are the same,
Wow.
right? Yeah, if they're the same, the exponents have to be equal, otherwise the equation's not true.
Right.
Okay, let's try one more of those. I want you guys to try this one. Let's see how you
So
do.
if you have the same bases, they just cancel out.
you're not really canceling it out, but if that's a true equation, the exponents would have to be equal, right? So you can just write the equation of the exponents then.
But like, when we're trying to do this, we practically think it out.
Sure. Talk to yourself however you need.
I
So
like
guys,
this
the base, what base are we using? 3, okay.
Yeah. I'm not wrong.
Because is it 3 to some power 27?
Yeah.
And 3 to some power 9?
Yeah.
Okay, that's what you want to go with. Figuring out like 9 to whatever power is 27, that is not pretty, so don't do that. Don't give me decimals.
Oh.
So I got 3 to the third in parentheses, up arrow, x minus 2 equals. What do you do for the
Up arrow. All right, I like what you said over here.
Okay, got that far. Okay. Now,
Okay, so first thing, 3 to what power is 9? Okay, but it needs to be, okay.
oh, okay, so that's easy. I just can't see, like, I feel a little bit confused with the whole fraction.
Oh,
When it's to a negative exponent, it's just like the number if it's positive, but in a fraction. And then what happens if it's a fraction? It's x equals 4 or 3.
root. Square root.
Oh, right, there's one half, like, oh yeah, I got you. Okay, yeah. Oh, okay, so then you just solve for the, oh wait, no, but then you have to simple, or distribute this guy. 3 minus 2, so 3x minus equals -2. Do my little addition problem. 3x equals 4 over that, respectively, it's x, wow, 4 over 3.
Good work.
Thank you.
All right, guys, we okay with those?
Yes.
Yes? We're getting it?
What?
No, apparently they don't cancel out, but you just, I think the cancel out is just.
It looks like it's not even bothering me. It's just.
It's what's bothering, it's like respecting the light.
Okay, we gotta do a little bit of domain work here, guys.
You're killing me.
Love this thing, love.
Oh, no, no. We'll just fire.
Okay, jot this one down. Phones away. That's you,
I'm trying to
Fletcher.
find a right now.
Every day. How do you not have this figured out? Every day you're telling me you're finding a right
I
now.
always am trying to struggle for right now, but I
Can
can't.
anyone be Fletcher's friend and give him a right
No,
now?
I got I just got them. Okay, so thanks so much. Wait, give me a right one.
Okay, domain. So you do not have to graph this to figure out the domain. You could if you really like graphing log equations, but you don't have to. So let's think about general log graphs. That's what you were doing earlier today. They look kind of like this, right? What is the domain of like the basic parent log graph? Zero to infinity, right? Like it can only be positive values. Okay? What that means for us is this in here, this x minus 1, can only be positive. So it has to be greater than 0.
So it has to be greater than, oh, so the x has to be greater than 1.
When you move the 1 over, yep. And if you wrote that with interval notation, that would be 1 to infinity.
Or you can just.
That's it. Think about it, guys. If you had graphed this, right? You'd start with your 2 points, 1, 0, 4, 1. And then you'd shift it to the right one, correct? So doesn't that make sense? Your domain, instead of being from 0 to infinity, is from 1 to infinity? Like it shifted right 1?
Oh, so it's like the asymptote.
Yeah, that's
So you don't bracket it. You can't have one.
right, exactly. You can't include the ones.
See, I feel like I know this until I see the quiz.
Yeah, you're doing fine.
Until I see the quiz.
Let me give you one more domain one that is a little trickier, okay?
So we don't have to worry about like log 4.
Nope, doesn't matter what the base is at all. All that matters is what's in parentheses here. Why can't I write it?
Oh, we just go back to it.
Okay, let's go through this one together, guys. So what's the only part of this I care about?
The base.
Not the base.
Polynomial.
Okay, that x squared,
That's past the factor.
yes. So this has to be greater than 0, right? Can we factor?
Let's see. 3, 2.
Okay.
Oh.
Look how fast. Priscilla, did you see that? Look how fast I got that.
That was not below average factoring
That was
speed.
pretty
Good
high.
job. No, we talked about this in Warhawk Talk. I'm not
Yeah, this
being
is
mean, okay? All right, how do I solve that?
Oh,
Done this.
tell me we do the number line with the positive negative. Ooh.
Number line. Don't cry, it's just a number line. All right, what goes on my number line?
Oh.
-3, -2.
Oh, so it's not the other guy?
Because it's what would make it 0. All right, what do you want to test that's easy?
0.
I would do 0. You could do 1 though. They're both fine.
Do 0 over here.
0's over here. Positive,
Positive.
positive, which is
Positive.
positive.
Negative. Positive.
Okay, it'll alternate, right? We know this now?
Yeah.
And we're looking for the greater than. So
Yes.
So it's the U thing, union, all that jazz.
All that jazz. Am I including the -3 and the -2?
No.
No. You guys are pros at this. Oh man. That is your domain.
Oh my god. You're really gonna have to reread it.
No, I think I'm just gonna go with this one because it's kind of funny.
I'm not actually gonna watch this.
Okay, it's up there. All right. Question.
Whoa.
Are we okay with this? Okay, let's stop here because we have all of 5 minutes left.
No.
Okay.
Take a 5 minute break.